an umbrella term that combines architecture, tools, databases, analytics, applications, and methodologies. All these facets are known as the BI landscape. I want to introduce myself, Greg Eslick, and Mike Morrison, my coworker here at the Rapid ILL project. We are a 22 fund organization within the Colorado State University Library System. We assist the administrative team of 7 members and direct operations of 2 separate vendors, totaling 9 IT professionals. In this presentation, we will walk through what is Rapid ILL, our history, product evolution, and our future BI directions. So what is Rapid ILL? It is a unique resource sharing system that was designed by the interlibrary loan staff at Colorado State University. This happened after a devastating flood in 1997. Some of you might have been around during that time, remember that event. What happened was the library's basement was flooded by water coming in through the windows, ironically in the office as we sit now, which filled the basement and destroyed millions of volumes of journals. What came out of that was a very fast, cost-effective article requesting system that was designed to supplement those damaged items. If you are affiliated with the university as staff, student, or faculty, you probably have done research through interlibrary loan, also known as ILL. Chances are high that you have used our services without even knowing it. The system originally was written in open source initiatives on Unix-based systems. That was in 1997 when right after the flood occurred. The main programs then were MySQL and Perl. In 2004, it was determined that the system was growing into something large that would benefit from an enterprise level model. The Microsoft layer was chosen to take us into the future. And at this time, I've changed the presentation over to Mike.
One area of business intelligence for Rapid ILL is statistics. 2 reasons for statistics. 1, provide our users feedback on their system usage. 2, to provide the administrative staff feedback on system operation. The initial implementation of our statistics was a custom script. This custom script would query a production SQL server, transform the data, and load it into a data mart. This occurred monthly. We also had custom reports that would display this data to our users. There were several technical issues with this implementation. 1, it was processor intensive, both on the client and the production SQL server. Secondly, because of the growth of Rapid ILL, this caused a problem in statistical calculation time. Initially, we had 15 clients. It took 2 to 3 hours. Not a problem. Once we exceeded 100 clients, it took 2 to 3 days. This became a problem. Third, any data changes required that we recalculate the stats. Again, when it takes 2 to 3 days, this can become very difficult and problematic. Fourth, it required personnel oversight. We were required to monitor the process and make sure it completed properly. There are also several customer issues with this implementation. 1, the calculations only ran on the first of the month, so sites could not see how they were doing in the system until the beginning of the following month. This lack of real-time data impacted customer employee management. Our customers wanted to know how many people did they need on staff to run this system. We could not give them real-time data to do that. Third, proactive system administration was also difficult because our administrative staff could not monitor the system to see how it was operating in a real-time basis. The solution was a Microsoft Business Intelligence solution. This included SSAS, SSRS, and SSIS. The ETL process. The ETL process consisted of two complex SQL queries. These SQL queries would query our production database, transform the data, and load it directly into the SAS queue. There were also several SSRS reports. These reports were stored on the reporting services, and it made updates and deployment of these reports easy when we used the SSRS infrastructure. SSIS jobs. We created several SSIS jobs to process the queue. However, there still was one technical issue with its implementation. It was still processor intensive. In order to process the SSAS queue, that could take in excess of an hour. This was a problem since we wanted to provide real-time feedback, 15-minute delays. We could not do this with the time it took to process the queue. The resolution to this was to create partitions. We realized that most activity within the Rapid ILL system took place within the last 10 days. So we created two partitions. One partition processed all data with 10 days or less. We call this the active partition. Any data over 10 days was in a separate partition called the archive partition. The active partition, 10 days or less, only took 45 seconds to process. Therefore, we could schedule this partition to process every 15 minutes and meet our goals of real-time data, 15-minute delay. The active partition, we could still schedule to run midnight off peak hour times to process the data within that queue. As a result of implementing Microsoft's BI solution, we were able to provide real-time statistical feedback, 15-minute delays. We were also able to provide our customers with dynamic data views, dimensions, by time or geographic location. We now can provide proactive system management. Our administrative team can now look at the system real time to determine if there was any issues. We also could do automatic statistics reprocessing. If any changes were made to the data within 10 days or less, it would be reprocessed automatically within 15 minutes. If it was more than 10 days, it would be processed that night. Now I'd like to do a quick demonstration of our statistics. In this screen here, we show a list of all possible reports for the Rapid ILL system. For this demo, let's look at the borrowing summary. Here we have 4 parameters that we can choose from. The first is a report view. The report view consists of calendar year or fiscal year. This is basically the time dimension. However, we have options to choose which view we want to look at. We will choose calendar year. Statistics to view. Here's a list of all the statistics we could view for this report. These statistics basically map to the measures within the SSAS queue, or the facts. We also have some calculated measures in here. Branch. Branch is geographical locations within the particular site we're looking at. In our case, we have 3 branches. We're going to choose all 3 of them. Request type. There's 2 types of requests you can make within a Rapid ILL system, article or book chapters. We will choose both. Now we'll click View Report. What this is doing is contacting the SSRS server, which resides on one physical server. The SSRS server then contacts the SSAS queue for the information requested. SSAS returns that information, the SSRS compiles that information, and presents this report to the user. As you can see, it divides it up by year. Let's expand the year. And then now it shows the months for this year. It goes through June, because that's where we're at right now. Let's take a look at June. And again, now you can see all the stats by days. And as you can see, it's calculating, giving you summary stats for each of those dimensions. Let's take a look at yesterday's data. Now what you can see here is you have the year, the month, the day. Now it divides it up by the branch or the geographical location for that particular site. Let's take a look at Morgan Library. Now it divides it up by article, and book chapter. As you can see, you can see the hierarchy of the dimensions as we expand them out. And then you get the summary data for each of those dimensions. With that, I will give this back to Greg.
All right, this brings us to trending. This graph here was generated some time ago, quite a few years ago, and the whole point of it was to monitor art growth and over this time frame. The time frame shown here is from 2006 up to current. What this graph does show is the increase in requests. You can see that our trend in the middle, the black line, has been very healthy over the years. And some interesting things that this graph point out are also that there's highs and lows patterns. The highs are the peaks of the semester when request volume is high, and the valleys of the graphs are typically over the if you pair them up, the difference is there. The lows are like the summertime months, and then there's a winter month is usually just December. So the peaks on the bottom that have 1 point are usually December, and the May, June, July are usually the valleys for summer. Now the peaks range from March, April to October, November, and those vary a little bit. So that's what we do with the trend graph. How do we use it as a resource to the administrative team is we loosely look at our hardware needs, our personnel staffing, and just general, how are we doing with the system? Are we keeping growing or not? Our next section is KPIs. We harnessed the ability to be more proactive about the data. Traditionally, we had challenges of people actually reading the traditional reports. We have full reports on all levels of the data, but we found a struggle with the team actually reading the data for important information. So we started using the KPIs to single out business metrics that would be most important to the success of our mission with Rapid ILL. We've categorized 4 here for you, and I'll just kind of explain how they work and what they are. We look at one metric where the number of sites is less than or equal to 5. We have some concern over, are they doing enough volume in the system? And typically, we look at that, and any of the metrics I talk about, we go to the site and we talk to them about how are they processing stuff? Can we do anything better? Is there anything we can work on with them? And that kind of aspect. Another metric we look at is the turnaround time in Rapid. Each member of Rapid is upheld a 24-hour commitment. So if their turnaround time average starts going over 24 hours, we'd like to work with them to make sure they can keep their commitment. Another metric we look at is sites that have less than 70% filled ratios. A typical ratio that is acceptable is in the 80% range, and if we identify the ones that are falling below that, we want to start working with them again to find out what's going on with their process. Another metric we look at is sites that are letting requests expire. If a request sits in their system for more than 5 days, it'll actually expire and go on to somebody else. And if that starts occurring frequently, we want to know about it and work with that site again to figure out what's going on. The way we deliver these KPIs is through email alerts. We do this once a week. Email will come in, and each metric measured has its own email with its own report. It seems to be working well compared to the traditional reports. Again, that challenge was, having the data there, but not, nobody looking at it to see what the problems were. So the KPIs have been very beneficial to our system. Our next section is, where are we going to go with our future BI plans? We follow, a cyclical development cycle. This is just a common model here where we define, plan, execute, evolve, investigate. And we follow that also with our BI model, not only our software development model. Some of the things we're doing to hold on a second, get off the slide here. Move forward is keep current on technologies. We find it very important to stay up to date with the latest software versions and tool sets. We do a good job of staying current with those. We also listen to our customers' feedback and provide them the information they need. So that's continued direction for our BI. That comes to our conclusion. If you want to know more about us, there is a Rapid website, rapidill.org. We put a link here also to the BI link at Microsoft, the tools we use. For this presentation, we use GoToMeeting in conjunction with a software tool called Snagit to record it. I want to thank you for your time and watching, and have a great day.